Hello and welcome to this video demonstrating the underlying principles of chromatography. Chromatography being an important method in separating, refining, and identifying everything from mystery powders to creating refined medicines. While the method we'll demonstrate is not used for much of anything anymore, it is the same basic principles. The advantages to this are that you can do this for yourself and see how it works without spending tens of thousands of dollars on equipment and hundreds of dollars, if not more, on reagents. Just about everything needed can be bought at a dollar store or other discount retailer. Chromatography requires a few things: your stationary phase, or the thing which delays and separates the parts of your sample; a mobile phase, which moves the sample; your sample, and for this we strongly suggest a dark ink, such as black ink. And in this instance, we're using paper towel, but you could also use a coffee filter. You'll need alcohol and some textures or ink. Unlike high-pressure liquid chromatography, ultra-high-pressure liquid chromatography, or gas chromatography, this is meant primarily to separate components out. In practice, a laboratory might use something similar in biochemistry. For that, a large column would be used and filled with silica, gel, or other semi-permeable material. The sample is put in the top and the mobile phase is added. This would then work its way down through the stationary phase. The stationary phase would delay some of the components and allow others to pass freely. That would have the effect of spacing them out over time. The same idea as how a pot still breaks down the different alcohols or flavors and releases them into different fractions. At the bottom, a spigot would be used to collect the fractions in certain time frames. These can then be analyzed for more detail. Unfortunately, this setup does not allow for the complex analysis that HPLC or gas chromatography does. It is by contrast much simpler and easy to do, if not as specific. Our example is similar, but works by capillary action drawing the mobile phase up, not gravity pulling it down. To set this up, you need a strip of paper towel or a coffee filter. Something like this is ideal. You want it to be reasonably consistent but somewhat porous. Add your ink to the bottom of these particular materials. Not at the very bottom, but slightly above that point, about 2 centimeters or an inch. Now add your alcohol to a shallow container. Put the paper towel on a skewer or chopstick to keep it suspended and reasonably vertical. Suspend the paper towel between 2 boxes or similar so that only the very bottom touches the alcohol. Over the next hour or more, watch as the alcohol is drawn up the paper towel via capillary action. It will reach the ink and cause it to become dissolved and drawn up the paper towel via the same capillary action. You will see over time that the ink is not made up of just one color. Multiple colors are added to the formula to provide the desired appearance. These will be allowed to travel through the paper towel at different rates. That makes them spread out and separate. Smaller dye molecules can move more freely, while larger molecules can move less freely. In other words, small molecules travel further while big ones can go less far. Ink is a useful example here as it is readily soluble in alcohol. There are other things you could try, but this is the key factor. The mobile phase must be a suitable solvent, or it cannot carry the sample via capillary action. Without that, you cannot get separation in the paper towel. Alcohol fits all of these requirements and is a very good solvent and moves very easily. Some dyes and inks can also be used with water, but it tends to not be as effective. It also doesn't separate out as well, so you get a more blob-like appearance without the nice banding you can see. While this is a very broad demonstration, hopefully it has helped to visualize and demonstrate why it is that things can be broken down and up in different ways with chromatography. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions that you have below.